Hello everybody and welcome to the video notes for Unit 4, Day 30. Sorry, I forgot to update this at the top. This should say Day 30 instead of Day 29. Today's video notes are dedicated to Andrea Lemos in 6B. Hi Andrea. In today's lesson, we are continuing our work that we started yesterday about determining if a number sentence is true or false, and if it involves variables. You can start by checking your answers for the opening exercise. And if you went through all of them, you would have determined that all of them are false except for in the row for 10, the last three here. Those are going to be true. Everything else, once you substitute the value in for the variable, it's going to be false. Now let's go down to this video notes section. It's asking us to state when the following equations or inequalities will be true and when they will be false. We're going to start with this top row. R plus 15 equals 25. Now, I think it's helpful to set up the equation where one thing you can do is leave a blank space instead of R. Plus 15 equals 25. Because this helps you think to yourself then, what number plus 15 would equal 25? Right? It's pretty similar to what you did in part 2 of your do now. Well, you can think 10 plus 15 would give me 25, right? 10 would have to go here for this statement to be true. So that means 10 needs to be the value for R for this to be true. So I can say that this is true when R is equal to 10. And it's false when yesterday, we did it a little bit different. Yesterday, I just had you provide one example of when R would be a false value. But instead, what we're going to do today is I want you to state all the situations where R is not true. So if R is only if it only works when R is 10, then R could not be 9, R cannot be 11, R cannot be 12, R cannot be 100. And the easiest way to say that is this is false whenever R is not equal to 10. The way that in math that we say not equal to is you draw an equal sign like I just did and you draw a line through it. This means not equal to. That's what that means, not equal to. So now that we've done this first example on your own, what I want you to do is I want you to try B and C on your own. And then when you are done, you're going to continue the video to check your work for those two problems. So let's pause and try those two on your own. And now you are resuming the video to check your work after you tried these two on your own. Remember, don't just start playing the video and copying it down. Try it on your own. Okay, so 6 minus D equals 0. I can think of this as 6 minus what number would give me 0? Well, I know that any number minus itself is equal to 0. So 6 minus 6 is what would give me 0. So that means that this is true when this here, when D in the second place is equal to 6. So the statement is true when D is equal to 6, which means that any other number besides 6 would make it false. If it was 6 minus 2, that's 4, not 0, so that's false. So I would say this is false whenever D is not equal to 6. 2 gold stars if you got that on your own. This next one, f over 2 means f divided by 2 equals 10. So you can think to yourself, what divided by 2 is equal to 10? Well, that's the same thing as 10 times 20. 10 times 20 is equal to 20. Right, up here? So 20 divided by 2 is what gives me 10. So I know that this statement is true when f is equal to 20. And it's not true whenever f is not equal to 20. 2 gold stars if you got that on your own. And now let's make it a little harder. Let's look at part D now, or number D. Right here. So here instead of an equal sign, we have the less than sign. And it's telling us that a minus 8 is less than 15. Now, I think it's easy to solve it by first changing this less than sign to an equal sign, and first thinking to myself that what minus 8 is equal to 15? So if I wanted this side, this left side, to be equal to this right side, which is 15, I know that a would have to be equal to, well, if I can add 8 to 15 to get 23. So that's how I know that 23 minus 8 would be equal to 15. So I know it's 23 minus 8 would be 15. So when a is equal to 8, that's when these two sides are equal. But be careful, because it's not an equal sign up here, it's a less than sign. So now I have to think to myself, if I want this left side to be less than 15, I need whatever's on this left side. I need all of this right here to be less than 15, which means that this number that I'm starting with here also has to be less than 23. So I know that this is true when a is less than 23. The 23 is coming from here. Right? Because think if a was 30, right? If a was 30, let's just do an example here, and it was 30 minus 8. 30 minus 8 is 22. Is 22 less than 15? It's not, so that doesn't work. It has to be some number that's less than 23. And if this is true whenever a is less than 23, that means any number that's 23 or bigger or greater is going to give me a false statement. So I can say that this statement is false whenever a is greater than or equal to 23. What this is saying here is if a was any number that was equal to or bigger than 23, like 25 or 30 or 45 or 60, when I put it back into here, I would get a statement that is not true, because whatever comes out on the left side would not be less than 15. Like in this example, when I put in 30, it didn't work because I got 22, and 22 is not less than 15. Okay, let's try one more together. Here we have 7g is greater than or equal to 42. Now, I can first start thinking of this as 7 times what would be equal to 42. So in this case, I know that 7 times 6 would give me something equal to 42. 7 times 6. And then I go back here and I look, okay, but I want the left side, I want this left side to be greater than or equal to the right side. So I need whatever is being multiplied here on the left to be bigger than 42. And I know starting at 6 is when it's equal to 42. So that means any number that I put in here that's 6 or bigger will make this true. For example, a true statement, that's why I'll put a T here, would be is when 7 times, let's say, 10, right? That would be 70, and 70 is greater than or equal to 42, so that's why a number like 10 works. So I can say that this is true when the value for g, whatever we put in right there, is greater than or equal to 6. That's where I'm getting the 6 from. And if all the numbers, when it's greater than or equal to 6, make it true, then I know it's going to be false whenever g is less than 6. For example, a false statement, I'll put an F here. Let's try the number, a number less than 6, like 4. That would be 7 times 4 is greater than or equal to 42. But 7 times 4 is 28, and 28 is not greater than or equal to 42, so that doesn't work. All right. Now we're on this last one. Y divided by 3 is less than 10. So I'll get you started by having you think about what number divided by 3 would be equal to 10. What number divided by 3 is equal to 10? Or 10 times 3 is equal to what? 10 times 3 is equal to what? And with this one, I want to see how much you can do on your own. So I'm actually not going to fill out any more of this for you. You're going to fill out the rest of this on your own, and when you're done, you can raise your hand, and I can check to see what you've done and make sure that you're getting it right. Today's secret word is swim, S-W-I-M, like what you do at a pool or a lake, swim. And with that,
thank you so much for playing my game.